Have you ever been playing a game and seen these incredible effects, like swirling fire portals, massive shockwaves, or just cool magical sparks, and wondered, how on earth do they make that? Well, in Unreal Engine, it usually boils down to two amazing tools working together: Niagara for the visuals and Blueprints for the logic. So today, we're going to pull back the curtain and break down how they work so you can start creating your very own awesome effects. So here's the game plan. First up, we'll get to know our two main players, Niagara and Blueprints. Then, we'll dig into the fundamental building blocks of any visual effect. After that, the fun part. We're going to build a simple fire effect, step by step. Then we'll see how to make our effects interactive, peek at some more advanced techniques, and finally, we'll wrap it all up with the key takeaways you need to start your journey.
So, what are Niagara and Blueprints, really? The best way to think about them is like a partnership. You've got an artist and an engineer. They both have very different jobs, but they absolutely need each other to get the final result.
And here's the core difference. Niagara, that's your artist. It's a whole system built to control how an effect looks. The shape of the flames, the color of the sparks, how thick the smoke is. It's all about the visuals. On the other hand, Blueprints is your engineer. It's a visual scripting system that handles all the logic. What does the effect do? When does it start? How does it react to the player? Niagara is the beauty, and Blueprints is the brains.
Okay, so to really get how Niagara works, let's break it down into its core components. A really good way to think about this is like you're following a recipe. You've got the final dish, you've got your main ingredients, and you've got the individual cooking steps. Niagara is set up in a very similar way.
So check out this hierarchy. Right at the very top, you have the Niagara system. That's the complete effect, the final recipe. Inside that system, you have one or more emitters. These are the sources, the main ingredients that generate everything. Emitters, in turn, create particles, which are just tiny little points of data that altogether create the visual. And what tells those particles what to do? Well, that's where modules come in. They are the individual instructions, the cooking steps.
Now, this is absolutely crucial. The order in which things happen in Niagara matters a lot. It follows this very specific flow. First, emitter spawn runs just one time, right when the effect is created, to get things ready. Then, emitter update runs over and over, every single frame. When a brand new particle is created, particle spawn fires, giving it its starting properties. After that, particle update runs every single frame for that one particle's entire life. And finally, the renderer takes all that information and actually draws it on the screen. Getting this order is key to making things work right.
Alrighty, enough theory. Let's get our hands dirty and actually build something. We're going to create a simple fire effect from the ground up using all the ideas we just talked about. Okay, first things first, we got to lay the groundwork. We'll start with a fresh new system and stick an emitter inside it. Now remember the emitter update section? That's where we'll add a spawn rate module. This just tells it how many particles to crank out every second. Then we jump down to the particle spawn section and add an initialized particle module. This is super important. It sets up how each particle starts its life. We'll give it a lifetime, maybe a second or two, and tell it what size it should be when it's born.
Okay, now for the fun part. Let's make this thing move and feel alive. We'll give our particles some initial upward velocity, so they rise up like real fire. But to make it look less robotic, we'll add a bit of randomness to that movement for a nice flicker. Then, in the particle update section, we can use a color over life module to make the particles change from bright yellow to dark red as they get older. We can do the same with size using a scale size over life module. A little bit of drag will make them slow down naturally. And finally, the most important step, we add a sprite renderer. Without this, our particles are invisible. This is what actually draws them on the screen.
So let's step back and look at what we've actually made here. Our emitter is basically a particle factory, just pumping out this steady stream. Each particle gets shot upwards with a little bit of a wobble to look natural. As it flies up, it starts to cool down, changing color from bright to dark, and it kind of pulses in size before it vanishes. It's pretty cool, right? We've combined a bunch of simple individual rules to create one complex, believable effect.
So, we've got this awesome fire effect, right? But it just sits there. What if we want it to actually do something? What if we want it to erupt when a player presses a button or appear on a magic sword? Well, that's where Blueprints come in. It's time to connect our pretty visuals to the game's actual logic.
And the real hero of this story is something called a class blueprint. Think of it like a master cookie cutter for an object. You can define everything about it in one place: what it's made of, what it looks like, and exactly how it behaves. Once you've made that blueprint, you can stamp out as many copies of that object as you want in your world, and they'll all work the same way.
Okay, so every blueprint has two core parts, and this body and brain analogy is just perfect. On the left, you've got the viewport. This is the body. It's like a little 3D workshop where you bolt together all the physical pieces of your object. Maybe a 3D model, a light to make it glow, and of course, our Niagara fire effect. Then on the right, you've got the event graph, and that's the brain. This is where you connect nodes and wires to tell the body what to do. It's how you program all the behavior without having to write a single line of traditional code.
Take a look at this. This is the logic for a simple interactive door. See those white lines? Think of them like a chain of dominoes. An event, like the player walking nearby, knocks over the first domino. That triggers a check to see if the door is already open, and if it's not, it starts an animation to swing it open. It's literally a visual flowchart that controls everything the object does.
So let's quickly break down the pieces we're using here. Events are the triggers, the starting gun. On-component overlap fires off when a player steps into a certain area. Nodes are the actual commands, the action blocks. Variables are the object's memory. For our door, a little checkbox called isOpen remembers if it's open or shut. Timelines are your best friend for animation. They smoothly change values over time, perfect for opening a door. And a branch is the decision maker. It's a simple if-then check that sends the logic down one path or another.
All right, now that we've got the basics down for both the visuals and the logic, let's peek ahead a little bit. Let's see what's really possible, because Niagara can create some truly mind-blowing effects.
This is where things get really cool. One of the most powerful ideas in Niagara is using forces and shapes. You're not just stuck spawning particles from one tiny point. You can have them appear in rings, on spheres, or even on the surface of a 3D model. And then you can push and pull them around with all kinds of wild forces.
And this quote from a tutorial about making a shockwave, it's the perfect example of thinking outside the box. There's this module called point attraction force, and normally it sucks particles towards a central point. But what if you give it a negative number? Well, it does the exact opposite. It violently shoves them away, creating a perfect explosion or shockwave. It's such a simple, clever trick with an incredible result.
And if that wasn't enough, Niagara also has some seriously advanced stuff like a full-blown fluid simulation system. This lets you create incredibly realistic smoke, fire, and liquid effects that can actually flow around and interact with things in your world, all in real time. But here's the really neat part. This super complex system, it actually builds on the exact same ideas we've already covered. You can take your normal everyday particles, and just by adding one special module, you can turn each of them into a little smoke machine. So if you wanted to make a swirling smoke portal, you just have your particles fly around in a circle and tell each one to leave a trail of smoke. It's that simple.
Okay, we have covered a ton of ground, from the absolute beginning to some pretty wild stuff. So let's boil it all down to the core principles, the key things you really need to remember as you start your own VFX journey.
All right, here are the 3 big ideas to walk away with. First, Niagara is modular. You build big, complex effects by stacking small, simple pieces on top of each other. Second, blueprints are event-driven. They don't do anything until something happens. They're always listening for a trigger. And finally, and most importantly, they work together. Blueprints are the conductor, and Niagara is the orchestra. One directs the action, the other creates the magic.
So, you've got the fundamentals now. You know how the artist works, you know how the engineer thinks, you have the tools. The only real question left is, what incredible effect are you going to bring to life first?